the King Kong banging on your chest. You could beat the
Good day everyone, my name is Ojabina Emmanuel. You are welcome to this class. In this class, we'll be talking about what we call the correlation and regression. So what is correlation? Correlation is when you want to find a relationship between two quantitative data. Correlation is when you want to find a relationship between two quantitative data. Let's say I have y, and I have what? I have x. So x must be quantitative and x must be quantitative and y must be what? Y must be quantitative. If I want to find whether there is a relationship between the y and the x, we make use of what? A correlation. Now, there's what we call a correlation coefficient. A correlation coefficient is what we call the R. The R is the correlation coefficient. The R is what? Is the correlation coefficient. So we have the R which is the correlation coefficient. Then the R range from, we have -1 less than or equals to the R. R less than or equals to 1. So we have -1 less than or equals to R. R less than or equals to 1. This is the value of the what? Of the correlation. This is the value of the correlation. That means that we cannot have a value that is what? That is higher than 1, or positive 1, and then we cannot have a value that is what? That is lower than this. That means that anytime you are having 1, which is a positive, that means that we have the what? We have the perfect correlation, which is what? They are what? That means that as y is increasing, x is also increasing. That is what? The perfect correlation. That is, let me say I have a line graph. I have a line graph like this, and I have this is my y axis and this is my x axis. That means if I put this graph like this, I have another point, I have another point, I have another point, I have another point. So this particular line like drawing this like this, that means that this is a what? A positive correlation. But when I have the other way around, let's say I have another graph like this, and I have this one is my x, my y, and this one is my x. If I have a point like this, I have another point, I have another point, I have another point. So this, if I have this straight line like this one is what? Is the what? Is the negative correlation. Is the what? Is the negative correlation. So by doing this, we can estimate our R through this line. But there is another formula in getting our correlation coefficient. So in getting our correlation coefficient, we have two methods of estimating the R. The first method is what we call the Spearman correlation, which is also that particular Spearman correlation is also known, that formula is also known as is the non-parametric Spearman. And then the other one is what we call a Pearson product correlation. So we are going to start with Spearman. So then after the Spearman, then we move to what? A Pearson correlation. Now, the formula for Spearman, the Spearman is where the Spearman SP, then we have what? 1 minus 6. The summation of this square, then we have n into n squared minus 1. Now, the D here means that the difference in the one will have x, then I have y, I have x. So if I have x, we call it Rx, and then if I have y, we call it Ry. That means the D now is now the difference between what? The rank of x and the rank of y. That is, I'm going to have my D to be equal to what? The Rx minus what? The Ry. So the rank between this and this is what we call the D. Now, after ranking them, then I will sum all the observations that I have. That is what we call the solution of. Then, after ranking them, then I will find the square of this. So if I find the square of this, that is what we call the D square. So after getting the D square, then I will sum everything, all the D square that I have. Immediately I sum everything together, I'm going to have the solution of what? The solution of D square. So I have the solution of D square. So 6 multiplied by the solution of D square divided by how many observations did I have? The number of observations is D, is the N. N is the number of observations that means the number of observations into bracket, the number of observations squared minus 1. So after finding everything here, then what? I'll support this from 1. When I support this from 1, I'm going to have what? The value for a what? For my Spearman correlation, which is what? Which is R. Now, what about the Pearson? The Pearson correlation. Now, the formula for Pearson correlation, we have what? The Pearson. We have the Pearson correlation. The Pearson. So the Pearson correlation now, the Pearson correlation, I'm going to have what we call, we have a summation xy minus summation x summation y divided by, we have the square root of, I have n, I'm going to introduce it, n into what? I'm going to have the summation of x squared, n as summation of x squared, then minus the summation of x all squared, then times, I'm going to have the same thing for the y. So I'm going to have n into summation y squared, then I have minus summation y all squared. So the square root is what is over this. So now, by the time this is the formula for what? For calculating what? The correlation coefficient for what? For using Capier's Pearson products. So we use this and this for what? The schema. So in our next example, we're going to apply this on what? On an example. So